Now let us solve a numerical from Fourier cycle. This is example 3.1, which is given at V. Ganeshan book, IC Engine by V. Ganeshan, at page number 121. The question is, what will be the effect on the efficiency of an Otto cycle having a compression ratio of 8 if CV increases by 1.6%? What will be the change in efficiency if CV increases 1.6% if the compression ratio of the cycle is 8? So let us write down in solution what is given first. Here compression ratio small r is given 8. CV increases 1.6%. That means change in CV by original CV. Change in CV is 1.6. Now it is given at 1.6%. So we can write change in CV by original CV 1.6 by 100. Now we have to calculate the change in efficiency of the cycle. As we know, all of you know, efficiency Otto is equal to 1 minus 1 by r to the power gamma minus 1. Okay. Now, according to this change in CV, we have to calculate the change in efficiency. That's why we need to draw a relationship between CV and efficiency. Let us see how. We know Cp minus Cv is equal to R. Okay. And Cp by Cv equal to gamma. Now in this equation, if we subtract minus 1 from both sides, it will comes, or 1 gamma minus 1 will be equal to Cp by Cv minus 1 will be equal to Cp minus Cv by Cv. Now see, this Cp minus Cv is our R. So we can write down gamma minus 1 equal to R by Cv. Now we can put the value of gamma minus 1, which is R by Cv, here in this efficiency formula. So we can write efficiency of this Otto cycle 1 minus 1 by R to the power, or whole to the power, we can write R by Cv. Okay. So you can see we are able to draw a relationship between efficiency and CV. Now we have to calculate change in efficiency of the Fourier cycle. How we will do that? Let's see. Let's rearrange this equation, or we can write 1 minus efficiency is equal to R to the power minus R by Cv. You can write this. Then if we take log or ln in both sides, ln 1 minus efficiency will be equal to ln of this, ln of power will become in front, ln of R. Okay. Now in terms of change in efficiency, if you want to write this, we need to do a derivative. That means small change in efficiency we need to calculate. That's why we will do derivative in both sides with respect to efficiency and CV. So ln of efficiency will be 1 by 1 minus efficiency into D of efficiency will be equal to minus R by CV minus R by, this part will be constant part, R ln R. Now we are derivating here in terms of CB, that's why 1 by CB will be 1 by CB square D of CB. Okay, actually we are integrating both sides. The integration of 1 by CB equal to 1 by CB square. Okay, our next step will be efficiency, D of efficiency by efficiency. We need to calculate this, that this is the change in efficiency. Okay, will be equal to 1 minus R. So differentiating, we are getting this value, we can write here differentiating both sides. So this will become into this fashion, 1 minus efficiency D of CV by CV. This is our change in specific at constant volume. And another CV was there, and we have put a efficiency extra over here, so we will put another efficiency over here. Now we can write this in this way, minus 1 minus efficiency. Our R by CB is already calculated, R by CB is already calculated, gamma minus 1, we will write down here gamma minus 1 ln R by efficiency D of CV by CB. See, this value is given, this value is given, we need to calculate this value. That's why we have to know the value of this efficiency, and we know the value of gamma is 1.4, and compression ratio is given, R is given as 8. So now we are calculating the value of efficiency, which is equal to 1 minus 1 by R is 8, R to the power gamma minus 1, which will be equal to 1 minus 1 by 8 to the power 0.4. we can write will be equal to 0.565, or we can write 56.5%. Okay, so now we can easily calculate this change in efficiency. This change in efficiency will be equal to minus of 1 minus 0.565, gamma, value of gamma is 1.4, minus 1 ln R, value of R is given 8 by value of this efficiency 0.565 into D of CV by CB is given already, change in value of CV, it is increases, this will be equal to 1.6 by 100. Okay, now if you calculate this by calculator, it will becomes minus of 0.01025. This will be equal to minus of 1.025%. This is our answer. This is actually, this much percentage of efficiency will change. Actually, this minus sign indicate the efficiency of the cycle, of the fuel air cycle, will decrease due to increase of specific heat at constant volume 1.6%. I hope all of you have understood. Next problem 3.2 is similar type of problem. where instead of Otto cycle, diesel cycle is given. So you can try it at home. If you don't understand, you can give me a message. Thank you. So let us solve another numerical from the fuel air cycle analysis. This is given at example 3.2 at page number 121 in IC Engine book by V. Ganeshan. The problem is, what will be the effect on the efficiency of a diesel cycle having a compression ratio 20 and a cutoff ratio is 5% of the swept volume if the CV increases by 1%? Take CV is equal to 0.717 kilojoule per kg K. R is 0.287 kilojoule per kg K. Now let us understand the problem first. The problem is saying, what will be effect of efficiency? Efficiency will decrease or increase when the CV will increases by 1% of a given diesel cycle which have compression ratio 20 and cutoff ratio is the 5% of the swept volume. CV and value of CV and R is given. So let us write down the given thing first. Here R is given, R equal to 20, which is ratio between maximum volume of the cylinder to minimum volume of the cylinder. Maximum volume of the cylinder is when piston will be at bottom dead center. Minimum volume of the cylinder is when piston will be at top dead center. That means clearance volume. Okay. Now, if say a engine start working from a zero position, suppose piston will be at top dead center and it will start moving downward direction as the swept will occur and suction process will occur. From this zero position or top dead center position, piston will move towards bottom dead center. Say this position is 1. So after suction process, the inlet port will be open, inlet valve will be closed, and again the piston will move towards top dead center from the bottom dead center. Say from position 1 to again at position 2. So R can be written as ratio between volume when the piston will be at position 1. You can say this is V1, and when the piston will be at top dead center, this position is 2. So volume is called V2. RC is cutoff ratio. What is cutoff ratio? Cutoff ratio is ratio of volume when the fuel injection process stopped and when the fuel injection process start. Suppose after compression in diesel engine we start the fuel injection. As we know, in this injection process cannot be occur instantaneously. It takes some time. That means it needs some degree of rotation of crank. That means it needs some movement of the piston. So if we start the injection process when the piston will be at top dead center, the piston will move gradually towards bottom dead center and injection process will occur. Suppose up to a certain position, say position 3, this injection process occur. In this volume, this injection process occur. So cutoff ratio is called where we stop this fuel supply or we cut off the fuel supply. So ratio of volume between position 3 to position 2 is called our cutoff ratio. So RC will be equal to V3 by V2. So it has been told in question that cutoff ratio is 5% of the swept volume. So how to calculate this cutoff ratio? Before we calculate the cutoff ratio, we need to calculate the swept volume, which is Vs. This Vs means swept occur of the piston from top dead center to bottom dead center. This volume is our Vs. From here to here is our Vs. So Vs means V1 minus V2. So we can write Vs equal to V1 minus V2. And we know V1 equal to, from this equation, from this here, we can write V1 equal to 20 of V2. So this will be equal to 20 V2 minus V1, V2 minus V2, that means 19 V2. So solid volume is equal to 19 into V2, 19 of minimum volume or clearance volume of the cylinder, 19 times of clearance volume of the cylinder. So cutoffs takes place 5% of the solid volume. So if this much is our solid volume, 5% of this is our cutoff ratio. So we can calculate this volume V3 by this. So V3 will be equal to V2 plus 5% of solid volume. 5% means 5 by 100 of Vs equal to V2 plus 0.05. Vs equal to, we can write again 19 into V2, 19 V2. So this will be our V3. So V3 will be equal to 1 plus 0.5 into 19, 1.95. If we calculate this by calculator, it will be equal to 1.95 of V2. Now if we put this value over here, RC will be 1.95 V2 by V2. So it will be equal to 1.95. Okay. So we have calculated the RC. Now we know the efficiency formula of an diesel cycle. Efficiency diesel we know is equal to 1 minus 1 by gamma 1 by R to the power, R means compression ratio, gamma minus 1 into RC to the power gamma minus 1 by RC minus 1. This is our efficiency of diesel cycle. So we can calculate when there will be constant specific heat not changing. We can calculate this efficiency value by putting the values. We know value of gamma is generally 1.4. Though value of Cv and R is given, we can calculate the value of gamma because we know Cp minus Cv is equal to R. Cv and R is given, we can calculate Cp, and Cp by Cv will be equal to gamma. So gamma will be, if we calculate this, gamma will be 1.4. So 1 by 1.4, 1 by 20 to the power 1.4 minus 1, 0.4. RC we have calculated 1.95 to the power gamma 1.4 minus 1 by 1.95 minus 1. So this will be our efficiency. If we calculate this by calculator, it will be equal to 0.649. This will be our efficiency of diesel cycle at constant specific heat. Now our aim is to calculate change of efficiency when there will be change of value of Cv 1%. Value of Cv will change 1%. We have to calculate that value. So from this equation, we can rearrange this equation like this. We can rearrange this equation like this. 1 minus efficiency will be equal to 1 by gamma Rc to the power gamma minus 1 R to the power gamma minus 1 Rc minus 1. So this will be our equation after rearrangement. Now taking log in both sides, the equation becomes ln 1 minus efficiency minus of, because 1 by gamma is 1 into this thing, minus of ln gamma plus of ln RC to the power gamma minus 1. In below there is R to the power gamma minus 1. So again we can write minus of ln R to the power gamma minus 1 minus of ln RC minus 1. This R to the power gamma minus 1 will come into front section. This gamma minus 1 will come into front section. We can write over here. Okay. Now we have to get a relationship between efficiency versus CV, because CV is only changing, no other thing is changing, and according to CV we have to calculate the efficiency change. That's why we know the equation gamma equal to Cp by Cv, Cp minus Cv equal to R. If you subtract both sides minus 1, so gamma minus 1 equal to Cp minus Cv by Cv, which is equal to R by Cv. Or we can write gamma equal to 1 plus R by Cp from here. We have this. Now instead of gamma in all places, we can put this value of this gamma. So putting this, substituting the value of this gamma, we can rewrite the equation like this: ln 1 minus efficiency 1 minus ln 1 plus R by Cv, putting the value of gamma, plus ln Rc to the power 1 plus R by Cv minus 1 minus of ln Rc minus 1, it will be keep as it is, minus here gamma minus 1 is here, value of gamma minus 1 can be put it, R by Cv into ln R. No problem up to this. Now what we will do, we will differentiate both sides. To calculate efficiency change, we will differentiate both sides. Let us write down again that thing: ln 1 minus efficiency equal to minus ln R by Cv plus 1 plus ln Rc to the power R by Cv plus 1 minus 1 minus ln Rc minus 1 minus R by Cv ln R. We have write down again the equation and differentiating both sides. Differentiating both sides, we get 1 by 1 minus efficiency, T of efficiency will be equal to, differentiation of this will be 1 by R by Cv plus 1, the whole thing, again differentiation of this thing, that will be R by Cv square d of Cv. Okay, plus differentiation of this 1 by Rc to the power R by Cv plus 1 minus 1, this whole thing, and again differentiation of this. To differentiation of this thing, we have to take log again. We have to say Rc R by Cv plus 1 x equal to this, take log ln again both side, it will R by Cv plus 1 ln Rc 1 by x dx by d of Cv will be equal to differentiation of this R by Cv square R by Cv square ln RC. Okay, so dx, differentiation of x, we have to calculate. We need to differentiate this. So dx will be equal to this, x will be multiplied this side, so this x equal to this one. So as it is cv square and whatever was there will be written over here, rc r by cv plus 1. This was x multiplied in this side, and d of cv multiplied at this side. So this is our differentiation of this part, because this is not a single part, it is a so many things, so we need to differentiate it separately. So we can put this whole thing over here above of this. This will be equal to r by cv square, or rc r by cv plus 1. Okay, ln rc d of cv. Now check, this is constant, this don't have any variable thing, so this part will be 0 after differentiation, and this have cv, value of cv, this will be minus of r by cv square, and constant part will be this is ln r d of cv. Okay, or now d of efficiency 1 by efficiency, take this d of cv by cv common from both sides, minus sign will be also common, r by cv have common, we are taking common these things, r dcv by cv square. dcv by cv is our change of dcv by cv is our change of efficiency, r by cv is latent separately, so this thing is r dcv by cv square, this upper part has been common out, so it will be equal to 1 by r by cv, whatever below was there will be left. We have taken minus common, so here will be a minus sign, and from here r by cv square already common out, dcv has been already common out, so rc r by cv plus 1 into ln rc will be left, in below whatever was that will be left, rc r by cv plus 1 minus 1, and from this part r by cv square dcv has been common out, so this was minus, this will be already minus is taken out, common out, so ln r will be left only. Now we can rearrange this equation, d efficiency by efficiency, this will be signify change in efficiency equal to 1 minus efficiency will be in this side, 1 minus efficiency will be this side, so we can write in this way, see we have put a efficiency over here, that's why we need to put another thing, but that both thing will cancel out and equation will be remain same, and this whole thing will be remain whatever within the bracket. Now we can calculate the change in efficiency in terms of change in specific heat at constant volume. This has been told is our 1%, that means this has been told 1 by 100, r by cv R by CV we can write down R by CV is as comma minus 1, because we have calculated R by CV before. So comma minus 1 here, R by CV equal to comma minus 1, so we can rewrite here comma minus 1 minus efficiency here R by CV plus 1 is equal to comma, so this can be written as comma minus RC to the power again R by CV plus 1, which is gamma, because here we have calculated already gamma equal to 1 plus R by CV. This will be equal to gamma ln RC by RC to the power R by CV plus 1, which is again gamma minus 1 plus ln R. This is our simplified equation. dCV by CV 1 by 100, because it is changing 1%. It is increasing 1%. Okay. Now this efficiency has been calculated already in previous section. We have calculated the efficiency 0.649. We'll just put the value right now. 1 minus 1 by 100. Value of gamma is 1.4 minus 1 minus 0.649 by 0.649 into 1 by 1.4 value of gamma minus RC is calculated 1.95 to the power 1.4 ln 1.95 by 1.95 to the power 1.4 minus 1, putting the value already, ln R is given, value of R is given, which is 20 plus ln R. Now if you calculate this by calculator, this will become 0.00565, which will be equal to 0.565%. This is the answer. The negative sign will be there. The negative sign indicates if value of CV increases, that means if value of CV in positive side, when variable specific heat will be considered, the efficiency of the cycle will decrease. That means if specific heat will increase, the efficiency will decrease. If specific heat will increase at constant value 1%, the efficiency will decrease 0.565%. This is the answer. Thank you for today. Hope you have understood.